All right, folks, today we're going to be working with that circle that we started talking about last time, and we're specifically going to reference what's called the unit circle. The paper in front of you has the information and definition of that. What I'm going to have you do here to start out with is follow the instructions on 1 through 3, and then answer question 4 based on what you came up with. Okay, so pause the video and try those now for me. Hopefully you understood by intercepts, I mean where the circle crosses the x and y axis. And using the definition, if this is at 0, 0, the center, and the radius is 1 unit, then around the circle I'd have 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Okay, and you were asked on number 4 to compare how these values on the unit circle with your degrees, since that's all we are working with here, compared to the trig expressions. And I was hoping that you noticed a pattern here. If we focus just on the 90 degrees values here, the 90 degree point is 0, 1, and those are the same values showing up here. Specifically, the 0 is giving us the cosine value, and the 1 is matching up with the sine value. And that same pattern holds true for all of these points. If you go to negative 1, 0, which is at 180, the sine went with the y value and the cosine went with the x value. So our pattern here is the x value of the point gives the cosine of the angle that rotates to that point. Same thing with the y value going with sine. But a little bit trickier was to talk about tangent. And 2 of the values for tangent were undefined. And in order for that to happen traditionally, we have a divide by 0 showing up. So if we compare those 2 points, the 90 and the 270, both of those have a 0 in the x position, which would mean this has to be an over x fraction. And then following the pattern that these other coordinate or the other coordinates involved somehow, then that would leave y to be on top. And that's going to work out for us because when we do that same thing here, it actually checks out and simplifies the same way. So when you go to the 180, if you take the y over the x, you get 0 instead of undefined. Okay, so what I want you to write on your paper here is, I don't want you to adjust any of that, but we're going to write a shorthand version of this. As a big ordered pair, the first slot is usually x. We're going to write it as cosine of the angle theta. And then the y value will do sine theta. And that corresponds to the x value and the y value. And we can also say that tangent was y over x, that is sine over cosine. Okay, so what we're going to do now is, instead of putting things in our calculator, because while these all came out to nice values, when we talk about sine, cosine, tangent in general of some angle, they're not always rational numbers. So what we're going to do is practice doing this using the unit circle in a pattern. So I'm going to do these first 2 with you, and then I'll let you work on the rest of them. Your job is to find the location on your unit circle. So if we think about this first one, 90 degrees would be up here, and the ordered pair for that is 0, 1. We decided that sine goes with the y coordinate of that ordered pair, so sine of 90 is 1, and that is one of the ones that you actually found up above in your calculator. This just goes the other direction. So the next one, what we're going to do is in radians, and I don't want you to convert because I don't want you to use your calculator at all here. I want you to just think about radians as what you learned about before. So I'm going to flash back real quick. These values from last time were pi over 2, pi, 3 pi over 2, and 2 pi. We know all the way around the circle is 2 pi, and each quarter circle is counting by halves. That's significant here because we have this pi over 2, or 1/2, showing up, but there are 7 of them. Okay, so we can count this by going, there's 1/2 pi, there's 2/2 pi, 3, 4, 5, 6, 7, just visually around this circle, which lands me at that point, 0, negative 1, giving my sine value negative 1. Okay. Another way you can deal with fractions on these is by changing them to a mixed number, if that's more helpful to you. So we can think of this as 2 goes into 7 3.5 times. So here, if we go back to our unit circle, this says 3½ pi. I know this is 1 pi, 2 pi, 3 pi, and then half of another pi, not half of a circle, half of a pi, which would put me down here again. So a couple different ways you can count for those ones. What I want you to do is pause the video and try the rest of those for me now, please. Okay. Hopefully it got a little bit easier thinking about your radian values. You had just a couple here. Most of these you can check in your calculator as far as the radian goes. If you were to type in these radian values, you would have to change your mode from degrees to radians in order to actually get the correct value. At this point, they're going to be rational numbers. That won't be the case down the road. Now, it's really important to me that you do this without a calculator. So you are required below each of these, because I will not be doing your homework with you, to watch if you are doing this without a calculator, that you show some sort of work. So you can do one of two things. Okay, you can write the ordered pair, or you can draw the visual where it lands, or both if it helps you. That's what I showed you in the first place, was actually visually drawing the point and then writing it. Okay, I don't want you to reference that original drawing unless you know that you can recreate it. Okay, because you will have to answer these just with a drawing that you make, not with your calculator. Okay, the next ones here are just going to ask you to generalize about what quadrant on the graph. So we're talking about the unit circle, but this is attached to a coordinate system. And just as a reminder, this part of the circle right here is in quadrant 1. This part of the circle is in quadrant 2, and 3 and 4 around. Okay, with that reminder, I want you to attempt problem 17, 18, 19. And what we're going to do is change our formatting once you come up with the quadrant that is the answer, after you have some time to think about those questions. Okay. So cosine, remember, is x, sine is y. When I say cosine is less than 0, I just mean negative x values, and that's the whole left-hand side of the graph. Then sine is the y value, so it's the whole upper half of the graph, and they intersect at quadrant 2. All right, over here, y we want to be negative down below. Tangent was a little bit trickier, okay, but I want you to focus on this as a fraction. When we talk about tangent being negative, it could be positive over negative, or it could be negative over positive, but one of those values has to be negative and one has to be positive. So that would happen in quadrant 2 and quadrant 4. So the overlap here is quadrant 4. Okay. Last one here, the first part was pretty straightforward. Cosine is positive, x is positive. But when sine is 0, that's not a quadrant at all. That's on your x-axis. And there are only 2 points where that circle intercepts the x-axis, here and here. And there's only one that is the winner. So this is not a quadrant at all. It's this point that was at 1, 0. Okay, but here's how the question is going to change. I just wanted you to start with these ideas, but what we're talking about here is not always a specific point. Sometimes it's a collection of an infinite amount of points, and there's no way for us to describe those without writing the equation of a circle, which we're not going to do. So instead, we're going to refer to it as the angle that would get us there. So the angle that would land us in quadrant 2, quadrant 4, or at that point. So your instructions on your homework, and from now on, will say, find the angle theta such that 0 is less than or equal to theta is less than or equal to 2 pi, which means we want our answers in radians that satisfies both expressions or both requirements. Okay, so what we're going to do here is talk about quadrant 2 in terms of our angles. So quadrant 2 starts at 90 degrees and goes to 180 degrees, but we have to change that to both radians and interval notation or set notation. I'll usually use interval notation, but you can use either. So here, 90 degrees is pi over 2. And if it's interval notation, we just put a comma here. And then 180 degrees is pi. And we have to talk about whether we include these values or not. So at this point, we're at 0, 1. 0, 1 does not have a cosine less than 0. It has a cosine equal to 0. So that does not work. We want to use a bracket. The same thing goes here. This ordered pair is negative 1, 0. It doesn't have a sign value greater than 0. It has a sign value at 0. So when we're describing quadrants that satisfy these, if we don't have an underline here, we are not going to include either side. Okay? On the next one, quadrant 4, again, we start with where it begins. We're going counterclockwise. So this is 270, this is 360. And we're changing that 270 degrees to 360 degrees to our interval notation in radians. So 3 pi over 2 is our starting point, again, not included, and we're ending at 2 pi. Okay, last one, a little bit different because it was a single point. We cannot write it in interval notation. The interval notation is only used for an infinite amount of values. Instead, we're using set brackets and just listing all of the angles that work. We only want the angles that work from 0 to 2 pi, so 0 would count and 2 pi would count in the case of this definition. The reason we're restricting it like that is because I could go 4 pi or 6 pi or 8 pi on forever and ever and ever. Same thing with these quadrants. I could add 360 to both sides continuously. We're not going to do that because there's an infinite amount of answers, and we will get about writing those types of formulas down the road. Okay, I'm going to do a couple of these ones with you because you'll notice we now have points that are not falling on the 1, 0, 0, 1, and so on. Instead, we're going to just talk about, in general, where these expressions would land and what part of the coordinate would be relevant. We're not going to focus on what is the actual value of the expression. Because if you put this in your calculator, it is going to show an irrational number. Some of these have exact values that we're able to find, and we'll talk about that next time. Right now, we're just going to practice finding location, specifically with our radian values, because they're the ones we're less familiar with. So this first one, it says negative 2/3. Remember, negative means clockwise. And we want to think about 2/3 pi as a fraction, whether that would land us on the top half of the circle or the bottom half of the circle. So going clockwise, 2/3 pi is not all the way to pi. So I know it's going to be somewhere in the bottom half of the circle. And if it's 2/3 of the way, there's only one point that could work, and that is ij. Okay, but not both parts of this ordered pair are the winner. Okay, when we're talking about sign, we just want the y value, which means our final answer will be the letter j. Okay, we'll do one more together here. This cosine, 7 pi over 12, much messier fraction, but we're going to do it the same way. Okay, this time we're going regular counterclockwise versus clockwise. And this 7/12 pi, we want to think about a fraction as well. I know that this is pi, and 7/12 is less than that, so I know I'm on the top half. Okay, but we have to decide, are we before that half mark or after? 7/12 is larger than half, so it has to be this EF. And the cosine is the x value, so our final answer is E. Okay, I did change this last problem. I had a mistake on there, so fix that. And then pause the video to try those last few. Okay, these are the answers you should have gotten. Really, the only things that I want to check on are your 25 and 26, talking about those fractions again. 5/3 pi, you can write this as a mixed number, 1 and 2/3 pi. We know all the way around is 2 pi, and we're not quite there, so it has to be KL. Over here, this is clockwise 11/6. Again, this is negative 1 and 5/6 pi, almost 2. Going backwards has to put me there, the CD. So pi over 6 and negative 11 pi over 6, ended up at the same point. I just asked you about two different expressions for those. Last thing we're going to do is talk about an application. Most of our application problems we're going to move to coming chapters. This one's just the basic on the unit circle, but I want to relate it back to the most recent thing we were talking about is with functions. And with functions, a lot of times we had not just a parent function, but a scale change or a translation or a reflection that added onto it. So in this problem, we're going to take the unit circle, which we know centers around 0 and has a radius at 1, and adjust it so that it would fit this problem here. So what I'm going to have you do is pause the video and try to talk through yourself questions right through the preliminaries, and then we'll talk about writing that equation with all of those transformations together when you come back. Okay, so pause the video real quick and try those questions. Okay, so this Ferris wheel is massive, okay? We not only have a huge number, like if that were feet, but that's in meters, which is ginormous. I gave you some pictures here to kind of relate size-wise. You know, in each of those 48 cabins, you can fit up to 40 people if you pack them real tight. Okay, this one had some furniture in there, so we're not seeing 40 people, but there's probably a dozen there. Okay, and they go around in pods versus the buckets that we're used to seeing. Okay, so we have to adjust the size of our circle to be that big. The first thing they asked you is what would relate to the height, the x or the y value. So if we're thinking about on this circle, we want to do the height would go with the y value. Okay, but the y value would really only get us this, so it's not the only thing we have to think about. So we're starting with that information. Then the next thing was our scale change. We didn't want this radius to be just one unit. We needed it to be a radius that's relevant to here. They gave us the diameter. We can split that in half to get the radius of that 115. Okay. Then what we're going to do is right now we've changed our scale and we know we're focusing on y, but we still have, this would be the ordered pair 0, 115. We still have some problems because I have a seat at the height of negative 115. And that's a problem. We don't want height to be negative ever. Okay, so now we're going to shift it out of the ground, and that distance is from the horizontal because all these pieces below that horizontal section are negative, and we have to fix that. But it's just not to just the bottom of the circle. We also have to include the little legs. Okay, so that was 135 meters. You could have done that by taking your 250 and subtracting off your radius. Or if the whole height is 250 and the diameter is 230, then this little piece here is 20 and add the 115 to that. Okay, so putting this all together, the y value tells us that this is the sine function. So we're not going to talk about the circle anymore. We're talking about the sine function, which only concentrates on the y values of that ordered pair. And the y values have all been multiplied by 115. So we'll put a 115 in the front. And they've all been shifted up 135. So that goes on the end. And now I have an equation with my independent variable being the angle of rotation from that center, because that's where we measure these parent functions, the sine, the cosine, those expressions from, to get the height of its corresponding seat. So the first one we're asked to find is CA, which is right here. And I know my equation. Our job is to find the angle that would relate to that rotation, starting at 0. So I want you to mark off this radius. It's very obvious. Even putting a 0 there would help. Okay, we're going to work in degrees because that's what we're most comfortable with here. And there's one other piece of information that was given to us. We don't know what this angle A is like instantly, but we were given enough information to find it because we were told that there were 48 pods going all the way around here. And that means there are 48 spokes going through. With that in mind, we can take our full 360 and split it up into 48 pieces. Which gives each little spoke a 7.5 angle difference from the rest of them. And that's going to let us find this angle A because we have to just go up 1, 2, 3, 4 of those. So to the side here, go ahead and write your formula, 115 sine, and leave some space for your angle, and then plus that 135. And this is going to come from just taking 4 times that 7.5, since we know that's how many sections would get us there from our starting point of 0. And then we can type that whole thing in. 115 sine, and then that's 30 close that, plus 135 for a height of 192.5 meters. Okay, and I put these markings on the side because it's a good idea to think about, is that number reasonable for what we know? We knew the wheel was 20 meters off the ground. We knew the center was 135 up, and we know the top of the wheel is 250, excuse me. So this A has to be somewhere between this 135 and 250, and it is. Okay. B is way up at the top. Hopefully you recognize that is not something you have to use a formula for, because the top of the wheel we already know is 250 meters tall. Okay, C we are going to have to do a little bit of work for. Okay, what I don't want you to have to do is count all the way around. Instead, what I want you to do is find the angle that you know that's closest to C and go from there. So the angle I know that's closest is down here is 270 degrees. So that means I just have to go backwards from that 5 sections. So here, my formula for part C would be 270 minus 5 times 7.5. And now I'm using that in my formula up here. Okay. 232.5. And gets us a height that we hope is reasonable. So 20 is here. 43.76-ish does not seem unreasonable because it's quite a bit closer to 20 versus that 135. Okay, so I'm going to call that about 44 meters. I don't care what you round to, but I would like you to indicate that you rounded. Make sure all of these get labels. Okay, I'm going to have you pause the video and do those last two, then you can come back to check them. Okay, this one should have been exactly 20 meters from the bottom, no work required. And then your formula for this one, we would have taken our 360 and subtracted 2 of those. Another thing you can actually do here, and I just want to talk about it because it may save you a little bit of time, we can always go clockwise. And 2 sections is worth 15 degrees, so you can also do a negative angle of negative 15 degrees and get the same value. Since you probably didn't do that, I'm just going to show you, type mine in, and you can compare it to yours. So 115 sine negative 15, and plus that 135. And it's about 105 meters, which is reasonable for this spot because it's pretty dang close to that 135. That's it. If you have any questions on your homework, please, as always, come ask me those questions when you have a chance.